And now it's time for the keynote talk this morning. Please don't forget to use Slack for the Q&A. So Philippe de Ryck helps developers protect companies through better web security. He is an amazing speaker. I personally have seen his talks before. His PhD in web security from KU lies at his basis of his exceptional knowledge in the security landscape. As the founder of Pragmatic Web Security, Philippe delivers security training and security consultancy to companies worldwide and has an online security course platform. Philippe is a Google developer expert and an Auth0 ambassador for his community contributions to the security of web applications and APIs. And now, without further ado, please welcome Dr. Philippe de Ryck.
All right, so good. I don't know, this is a worldwide event, so it's good morning for me. So let's call this good morning. Good morning, everyone. It's actually quite an honor to be here at OWASP's 20th anniversary celebration for the opening keynote. And I would love to say that I've been a part of OWASP for those 20 years, but that's not entirely true. I probably was there for a majority of that. I've been involved in plenty of OWASP events, but some amazing people have pushed this the full 20 years, and that definitely deserves a celebration. I'm going to talk about a topic, AppSec is too hard. That's the title here. And the message or the content of this session, this keynote, is actually quite fitting for an event like this, because we're going to celebrate the fact that OWASP has been around for 20 years. I'm going to highlight a couple of cases where we actually push application security forward. But I'm also going to conclude that we have some work left to do if we want to actually get towards building more secure applications. It's basically a never-ending story, but hopefully we can keep improving and make things better. When I was this talk has been simmering in my brain for a while, so it was basically waiting for a good opportunity to come out and allowing me to share a couple of my thoughts on application security. And one of my working titles for this talk was a bit more dramatic. It was like, the road to AppSec hell is paved with good intentions. And it's a pretty cool title, and you can go all kinds of directions with that title, and that's why I kind of liked it in the beginning. But the more I started thinking about the message and fine-tuning the message I wanted to bring, the less the title connected with me. Because, well, there's two parts in it, and the second part, the good intentions part, is definitely there. I'm going to show you a couple of things of how we as a community of security people, of developers, try to push security forward, and we try to do a good job, and we definitely try to make things better. The problem is those good intentions, they lead to some issues. We're going to talk about that in a minute, but they don't necessarily lead to AppSec hell, because that's AppSec hell is very dramatic, and it means a different thing for different people. But to me, AppSec hell would mean a scenario where companies have, or developers have, no security awareness at all. They have no idea what they're doing, or they don't even care about security. That's AppSec hell to me, and that's not what I'm going to talk about. I mean, that's a whole different problem with all kinds of solutions, but that's not something I'm going to be able to address in a 45-minute talk here at the celebration of OWASP. By the way, this picture, really awesome. This is an actual picture of a hole in the earth in Turkmenistan, if I'm not mistaken, where they were mining natural gas a couple of decades ago, and things went wrong. So they decided that the best course of action was to light it on fire, and it has been burning ever since. You should look it up. It's actually pretty awesome. That aside, let's not talk about AppSec hell. Let's talk about developers trying to build secure applications. That's my premise here. Most developers that I meet, or virtually every developer that I meet when I handle security for companies, when I teach them about security, they all want to try and build secure applications. They do their best. And that's the premise I'm going to take for this session. Developers do their best, and they still fail. That's the key thing here. Even with all the efforts that we have, we still fail at building secure applications. And I don't think that's acceptable. Yes, there will always be issues and will never be 100% secure, but the way things fail today there's some serious issues with that. And what I'm going to try to do is explain why these issues exist and also propose some potential solutions, not silver bullets, but approaches we can take to try and get things better. That's essentially a preview of the main takeaway of this session. All right, so I'm going to use a couple of cases to do that. And the first topic I want to talk about is JSON Web Tokens. And a slide like this is kind of where I miss real world events, because if the room would be full of people, it would be very interesting to see the reactions of people. I'm pretty sure that some of you would be like, oh, Jesus Christ, JSON Web Tokens. Or some of you will be like, oh crap, JSON Web Tokens, we use that. So security might be pretty important here. For now, I'm just going to guess what you're doing. And that's going to be safe enough for now. So JSON Web Tokens, they have a few pros and cons. One of the major pros is the fact that it's not XML or YAML, so it's JSON. So in modern applications, JavaScript-based applications, JSON is actually a pretty easy format to work with. One of the cons of JSON Web Token is that they have some security issues. And it depends on who you ask, whether they have some or a lot, but there are some things with JSON Web Tokens that you should be aware of, and there's definitely things that go wrong. So let's look at a couple of examples here. First, let me give you a bit of introduction or a bit of background information about a JSON Web Token, just to make sure that if you're not fully up to speed with all the technicalities, that you'll at least be able to follow the story that I have to tell here. What you see on the left, the pretty colorful string, that's what we call a JSON Web Token, and it's an encoded piece of data. And it consists of three aspects. You have the header, that's the first part, the red part. You have a payload, that's the actual data, that's the purple part, as the way it's visualized here. And you have the blue part, and that's a signature. And the first two parts, as you can see on the right, in the decoded version, are basically JSON objects in a base64 encoding. So it's not encrypted, it's just encoded so that it's kind of safe to send around in URLs, because new lines and braces, all of that stuff doesn't really belong in a header or a URL or something. But if you encode it in a base64 encoding, then this actually works quite well with web applications. All right, that's the premise here. So that's the setup of a JSON Web Token. That blue part, that's not a JSON object, but it's a signature. Well, it's either an HMAC or a digital signature, and that is very crucial to ensure the integrity of the header and the payload. So basically, the entity generating this token will sign it, so that if somebody changes something in between, the receiver will be able to detect those changes. That's the idea of that signature. Otherwise, if I'm a malicious user, I could take this JOT, change the user ID, add some roles in there, and send it to the server, and the server might accept that, which would be kind of problematic. So the signature prevents that from happening. And you sign that with a secret, which probably shouldn't be on a PowerPoint slide. It shouldn't be super secret HMAC key, but that's a discussion for another day. But this is what JSON Web Tokens are: a way to represent some data, the purple part, in a secure way by adding integrity. And they support some advanced features as well. How are JOTs used in practice? Well, in a lot of cases, JOTs are used to contain authentication and authorization information. And I'm not going to talk about whether that's a good idea or not and the pros and the cons, because there's a whole bunch of those, but that's the reality. That's how we use JSON Web Tokens today. And that can be a custom built mechanism, as you often find in smaller applications, or it can be a mechanism that uses OAuth or OpenID Connect, which is what you'll find in larger enterprise applications. But under the hood, they use JSON, typically use JSON Web Tokens as technology. Now, with JSON Web Tokens, there are a couple of things you should be aware of as a developer. Otherwise, things like this happen. This is a story from 2 months ago, 3 months ago, whatever, beginning of June. There's a project, an open source project called Apache Pulsar, which is some kind of a server-side messaging framework. I'm not too familiar with the product. I'm more familiar with the vulnerability that is covered in this story. And they had a problem with the way they handle JSON Web Tokens. And somebody figured that out and reported and fixed it. And of course, the whole story evolved from there. What's going on here? What's the problem that actually happened? Well, The article is from the Daily Swig, which is maintained by Portswigger. It's a really good source of security information, or incidents for that matter. And they include a lot of context. In this case, they also included a link to the GitHub pull request to fix the problem, which is awesome. I mean, that's the stuff I'm interested in. So I went there and I grabbed a screenshot for your entertainment, I would say, or your education. That's better, not entertainment, education. This screenshot fixes the problem. And this screenshot, you can play a game with that. A game my kids love. Find the 5 differences between the left and the right. Well, actually, diffs on GitHub make it easy because they highlight the differences. But even within those highlighted lines, the red on the left and the green on the right, it's going to be really hard to find the difference. There's some semantic stuff, but in the end, the only difference is the end of that statement. On the left, it says parse with a token. And on the right, it says parse claims JWS with a token. And the left is vulnerable, and the right is not. Huh. That's interesting. Things like this make me wonder, like, why did the developer write parse instead of parse claims JWS? How does a vulnerability like that come into existence? And the reason I think about that is because I teach people to build more secure software. So I kind of have to put myself in their shoes and figure out what is going wrong so we can actually try to fix it. So what I did here is I built my own very little code example. I'm a master developer, so I wrote 3 lines of Java code and I felt like the king of the world when I did. No, I'm just joking here. Here's how this is a Java library to handle JSON Web Tokens. And this is basically how you write that code. So you have the parser builder, you give it a signing key, which is necessary to verify that signature. You build it, and then you have to parse a JSON Web Token with that parser builder, well, that parser basically. And when you autocomplete that, you get 6 functions that start with parse. 2 normal parses, 1 parse claims JWS, 1 parse claims JWT, 1 parse plaintext JWS, and plaintext JWT. Huh, interesting. Apparently, the first one is wrong and the third one is right. I don't know why. This is really hard to figure out why which one you should use, right? If you're relying on IntelliSense to autocomplete this, honestly, I have no idea. I'm pretty familiar with JSON Web Tokens, like really deeply familiar, and I have no real idea why I should use one or the other, which is pretty interesting. But of course, we shouldn't rely on method names only to find the right way to do things. So let's look at the documentation. Well, to be fair, I didn't spend days looking for the right documentation. I Googled for a few minutes and couldn't find any rendered Java docs hosted online. But not to worry, this is an open source library, so you can go to GitHub and read the code. And the code actually does have some documentation. Awesome. This is the JWT parser interface, and it defines that parse function that's apparently insecure. I'm not expecting you to read everything. I'm not going to read everything out loud either. But if you scan the text at the top, there's nothing that jumps out to me that says like, hold on, this is not good. This is like, yeah, this parses a JWT. I mean, this kind of makes sense. But is it secure? Well, it throws a signature exception in case the signature is invalid, so we can discard the token as untrusted. That means somebody has been messing with the token. Interesting. So it does signature validation. So as a security expert, I can't tell you if this function is secure or insecure. Well, I can tell after reading that article at the Daily Swig, but without that context, I would have no idea. And if you write some code to test this out, you will actually discover that parse is indeed insecure and parse claims JWS is secure. And that's because of a weird thing in JSON Web Tokens. And that weird thing, well, it's not that weird, but that weird thing or that problematic thing is the fact that you can configure a JSON Web Token by setting ELG to none. And ELG is a claim in the header. It's metadata about the token that says this token is signed with this algorithm. None. It means exactly what you think it means. No signature. A token signed with none, well, it's not signed. A token without signature with ELG none doesn't contain the blue part, the signature part. It actually has a header, a dot, the separator, the payload data, a dot, and then nothing. And this is, according to the spec, a valid JSON web token. And one of the problems is that the libraries handling JSON web tokens implement a specification, kind of like they're supposed to do. And that means that they often have a code path that says if ELG is none and there's no signature, we can just trust the token as it is and return the data in the payload. And that's exactly what the parse function in that Java library allows to happen. And the parse claims JWS knows like, no, it has to be with a signature. So I'm going to expect the signature and I'm going to fail if that signature is not there. But the only way I could figure out that behavior is by writing a simple application that tries these things out to see how the library behaves. And you can kind of see that that's probably not the best way of handling things. And this problem is really common, by the way. This is one of the saddest parts of JSON web tokens. The fact that the spec allows that is one thing. It's not that uncommon because the SSL and TLS specs also allow to run TLS without any encryption, for example, which nobody does in practice, but it's in the spec. And the same thing happened here. The problem is that libraries implemented this, and actually a lot of libraries allow this by default, which is a problem because now the attacker can generate a token like this, put arbitrary claims in there like, yeah, I'm Philippe and I'm an admin, and send it to the server, and Apache Pulsar in our example would accept that. And this problem exists in quite a few applications. And it happened at Auth0 as well. So the problem was in a lot of libraries, it was discovered in 2015 in most libraries that they supported this by default, and people patched libraries to make it a bit more difficult to accept such tokens. And some applications that were using those libraries didn't immediately update. And instead, they added a check in their code that says, if ELG is none, I don't want your token. So it's a simple code-based check that rejects tokens that are unsigned and only allows signed tokens. At least that's what we thought that would happen. But the thing is, some attacker figured out that if we put none in capitalized letters, at least some capitalized letters, that it would bypass some of these checks because they only check for the lowercase none, and it would still be accepted by libraries. So this weird capitalization thing is an actual bypass against code-based checks on ELG none, which is why code-based checks are not a very good idea, even though they happen in practice. By the way, this was a hard lesson for Auth0 to learn, and they actually concluded that they should increase their security efforts and have been doing ever since, which is good. But this ELG none problem it's kind of a nail in the coffin of JSON web tokens. It's something that people really, really mess up quite often. It's actually so bad that some people with a profound hatred for JSON web tokens because of problems like this built a website that says how many days since the job elgnone.vuln.com. And that website tracks cases where this ELG none vulnerability pops up and causes a problem. And this is an old screenshot. There's new, this one is longer ago for one, and there's new cases on there second. But this screenshot has a very interesting takeaway. The takeaway here is that this happens in modern applications, because I'm pretty sure that the UK NHS COVID-19 contact tracing app was only built in 2020, yet it still contains this vulnerability that we've known about for at least 5 years. We still managed to build modern applications containing that same vulnerability. And attackers know about this too. And Burp Suite, a pen testing tool, even has an add-on that allows you to mess with JSON web tokens. And one of the options you have, it's like a drop-down ELG none, click. You can even choose your capitalization, and boom, it will generate a JOT for you without signature. So you can test if a service accepts that JSON web token. And if it does, like Apache Pulsar, you have found a massive vulnerability. And that's something you need to address immediately. And that brings us to a first takeaway here. And the first takeaway is low level and technical, just because I want to get this thing fixed in as many applications as possible. You should have test scenarios for your APIs, for your applications that test for these common pitfalls. And one of the things I always work with customers on security quite a bit, And I help them write these tests. Whenever you have an endpoint accepting JSON Web Tokens, like Apache Pulsar had, you should have a battery of tests that throws invalid tokens at that endpoint, like wrong signatures, modified payloads, and so on, and they should be all be rejected. And a bunch of those tests should be ELK non-tokens, like just throw it at your application and see if it comes back with an error, preferably not with all good. And if it actually throws an error, good, because now you know that you have covered that use case. And if it accepts that token, you have found a vulnerability that you can fix immediately. Really, really important. Now, I'm sure a couple of you are thinking like, if JSON Web Tokens suck so hard, why are we using them? And that's a question I actually get quite often. And there are some alternatives. By the way, the people behind that website tracking the ELK non-vulnerabilities, they hate JOT so hard that they proposed an alternative called Pasito. But these alternatives are not very widely supported. So one of the strengths of JOT is wide library support for every language. The alternatives, not so much. They're also not compatible formats. So if you want to switch token formats, it requires a full update of your application, which is fine if you have one app handling JOTs locally. If you have like an application suite, if you have central services issuing JOTs, this is going to be an update nightmare, not something you do very easily. And third, maybe that's the most important argument why I'm not a big fan of throwing out JOTs. It's because they're not going to go away anyway. JOTs are heavily used in OAuth and in OpenID Connect, which are kind of getting more and more popular to implement authentication and authorization at scale. So you'll have to be able to handle JOTs securely anyway. So why push for an alternative if you're going to have to use both if you're using any of the industry standard OAuth implementations? I don't think that makes much sense from a manageability aspect. All right, so AppSec is too hard. That's a statement. It's not a question anymore, it's a statement. Taking this example, AppSec is absolutely too hard. I mean, 6 functions, good luck figuring out which one to use. And this is only one library. There's a couple of Java libraries, and I know at least another one that has a decode and a verify function. Use the wrong one and you get screwed over. And there's problems with other libraries as well in other languages, Ruby and JavaScript and so on and so on. And that's only verifying the signature on a JSON Web Token. There's actually quite a few other things that you have to take into account to handle JSON Web Tokens correctly. And I want to walk you through them, not in detail, but I just want to give you a quick overview so that we have a very good idea of what we ask from developers as a security community. If you want to use JSON Web Tokens, you have to choose the signature scheme because there's 2 ways to sign a JOT. One is adding an HMAC. The other one is adding a digital signature generated with a private key. I'm giving you a nudge here because the HMAC thing is kind of useless in most scenarios because it relies on a shared secret. So you probably want to use digital signatures. But to figure this out, to make an informed decision as a developer, you would have to know about the security properties of both. So you can think like, oh yeah, I actually need this one, not that one. Let's say you want to use digital signatures. Now you have to decide on a signing algorithm. There's a couple of options here. And they have very meaningful names. You have RS256, PS256, or ES256, or EDDSA. It's like, okay then, I don't know. Most common is RS256. That's an RSA-based signature, uses SHA-256 under the hood, and it uses a specific padding, PKCS something something. That's most popular. A lot of services use that by default. But interestingly enough, there's an RSA crypto spec that says like, yeah, this way of generating signatures, it's okay, but we kind of expect that this will not hold out very long in the future. So we kind of deprecate that in favor of other approaches, which is already a big conflict. JOT says like, yeah, I use this, everybody uses that. And the RSA people are like, yeah, I'm not sure if that's a good idea. So my recommendation here, without going into the details, would be to use PS256, uses the same keys as RS256. So it's a real easy upgrade path and it offers better security. The only downside is support is a little bit less, If you use a good library, you'll find support for that without trouble. All right, next step. Once you actually handle a JSON Web Token, you have to verify the validity. And that means correctly verifying the signature. That's selecting the right function from that list of 6 that you had available in that Java library. And next, you're supposed to check some timestamps. Best practices for JOTs require you to include timestamps, such as an NBF, a not before claim, and an EXP, the expiration claim. You have to make sure that these define a time window that is acceptable to you. And then typically you'll find ISS and AUD claims, the issuer and the audience, who has generated this JOT and who is supposed to consume this JOT. Best practices, again, if they're present, you have to check that these values make sense to you. And these are only the basics. That's the minimal level of security you need to handle JOTs. In reality, you're probably going to have to deal with key identifiers, because when you generate a JOT, you can include a hint like, hey, you should use this key to verify it, so the receiver can look up the key in a key store, or use a discovery protocol to obtain the keys, or whatever works for you. And you're also supposed to set an explicit type for a JSON Web Token. That's something that was discovered more recently. It's a token confusion attack where 2 tokens have different purposes, but they look very similar. OAuth and OIDC have such a problem, for example, and it's best to include, or it's always best to include, a specific type in the header telling the receiver exactly what the token is supposed to be used for. That helps to avoid token confusion attacks. This is what I teach in my training classes, what I've been teaching for a while. And I've also been wondering for a while, is this really the best way? Is this how we teach people to build secure applications? Does this work in practice? And most importantly, can we expect developers to know all of these details before they even start using JSON Web Tokens? I have an answer, I have an opinion on this, but this is actually kind of a rhetoric question. Can we expect that from developers? Does that make any sense at all? In my opinion, I don't think so. I don't see a path towards the future where this is going to work reliably. That's why I want to advocate for taking all of this crap, this responsibility, away from developers. And that doesn't involve building a new standard that makes a couple of these decisions for you or makes it more easy to make those decisions. No, that means your security team, your security champions help developers in a way that they don't have to worry about that. Instead of writing this JOT parsing logic yourself, why don't we build a security library that handles our incoming token? Why don't we provide the right level of abstraction to handle that in a reusable library? Hey, developer, you get a token and you want to make sure it's valid? Call our verify authentication token function. It knows about which algorithm, it performs some security checks, it checks lifetimes and issuers and audiences, and it makes your life a hell of a lot easier. That's a really, really powerful pattern. And I honestly think that this is the way, and it has been shown that this actually works really well, that this is the way forward to help people build more secure applications. And this takeaway, this slide here, is maybe the most important takeaway from the entire presentation. By encapsulating security behavior, by offering the right abstraction, we absolve a developer's responsibility. The developer is no longer responsible for making these detailed security choices and risking getting it wrong. I'm going to come back to this pattern a bit later in this session as well. This is kind of funny because as I was working on this presentation, this idea last week, there was a blog post from Netflix on how they secured Netflix studios at scale. And the post makes a very similar conclusion. They try to work with development teams on integrating security in their apps. And the response was like, yeah, we don't have time for that. Go away. Yeah, we'll do it next sprint, which never happens because it took quite a bit of effort to integrate security in the applications. They had massive checklists of what you're supposed to do, and it simply didn't work. And the approach they eventually took was they said, like, you know what, we're going to build a product, a security product, internal product that people can use to set up a new application. And while we do that, we handle a couple of tasks that they have to do anyway, like generate domain names and this and that. And in the end, we give you an application that has a WAF in front of it, authentication in front of it, logging and monitoring setup, allowing a developer at Netflix to go from 0 to a deployed application with authentication in 10 minutes. And that's what pushed a lot of people towards using this product. It made their lives easier and it added security at the same time. And you can do the same with your internal libraries. You don't have to go the full Netflix route by building extensive products to handle these things. But if you have a well-designed security library, you can reuse that across different applications. Because we all know that if you work at a company, you have different teams that all have to repeat the same task over and over again with the risk of getting something wrong. But if you have a manageable tech stack, then you can easily build a shareable library that handles a couple of these details automatically. And what's even better, doing so, encapsulating that logic into libraries gives you flexibility as well. You want to upgrade your JOT signing algorithm from RS256 to PS256? Great. You update your library where you generate and verify JOTs and you're done. You want to change the token format to something else? Be my guest. You change it in one place and the rest of the application doesn't even have to care about the fact that you're using a different token format. That's a big win in my book. And what's really interesting is that we actually learned about this encapsulation pattern at university when we're learning software engineering. At least in my education, that was a big thing. And what really struck me when I was making this point in preparing this presentation is how you kind of know it's a good idea when you learn about it, but you don't have the experience as a student to see this in action, to see the benefits in action. And now this actually culminates into something really useful and something that helps us build better and more secure applications. And that's actually pretty awesome. All right. Enough about JSON Web Tokens. Let's talk about something completely different. Let's talk about React. React is this was not smart for me because I don't really know how to define React. There's a couple of different opinions. It's not really a framework. It's more of a component library, I would say. Whatever, doesn't matter. React is a JavaScript project, let's call it that, a JavaScript project that will help you build front-end applications. It basically allows you to generate smart application components or even full templates by using HTML, adding some data into that HTML, allowing you to make beautiful applications. Awesome. You probably know that whenever you're building something with HTML, cross-site scripting is definitely a risk. You have to worry about cross-site scripting. That's always been part of the OWASP 10, and that doesn't change in 2021. And I'm giving spoilers about the OWASP 10 now, but it's kind of public knowledge, so this is good. There's been a release candidate available for a while. So what's cross-site scripting? In a very short nutshell, cross-site scripting is a problem that happens when you get some data from the user, from a malicious user or an external source, and that data contains JavaScript code that the browser will execute. Because this allows me as a malicious user to write a restaurant review, drop some malicious code in there, and it will execute in all of your browsers when you look at that restaurant review. So what's going to happen if we take this review data in the second block and put that in place of that review placeholder on line 3 in the React template? Well, this happens. It looks like crap. Granted, that's true. Well, first of all, because I'm not a very good designer, and second of all, because React is rendering that data as data. The browser doesn't see this as code. The browser doesn't parse HTML because React knows that what you're doing is potentially dangerous. And it says like, yeah, let's not be insecure here. Let's actually escape the data before we put it in the view so we don't risk or cause cross-site scripting vulnerabilities. Awesome. This is a major step forward for security. And by the way, all the major JavaScript frameworks do it. Angular does it, Vue does it, Ember does it, React does it. If you happen to use a framework that doesn't do this, my advice is to drop it and use another one. Seriously, if they don't do this, I would not trust that for anything else as well. Secure by default. Awesome. As long as you use these braces in React, you're covered against cross-site scripting in scenarios like this. That's good. That's all nice until somebody comes along and says like, yeah, I want to render something pretty. I had a CK editor component and somebody gave me a document, and behind the scenes, CK editor generates HTML with headings and paragraphs and images and captions and so on. And I want to render that. And if I put that between braces, it looks like crap. And yes, it does look like crap. Not beautiful like it should be, as on this slide here. So as a developer, you're like, oh, crap. How do we fix that? And there's a way in the browser you can assign HTML to an element. It's called inner HTML. And it's dangerous. So React says like, yeah, this inner HTML thingy causes quite a few problems. You know what? We're going to call this dangerously set inner HTML. And you can see where this is going, right? You're smart people. You know where this goes. It's a dangerous property. So if you use that property and assign the data the React way with __HTML, that's to avoid accidental misuse by autocomplete. If you assign a review and the data is that, you will get the HTML. It looks a lot better. My design is still crap, but the HTML is actually rendered now, which is awesome. But you also get a very beautiful alert dialog. Not good. Why? Not because the alert is annoying. Yes, it is, but that's not the point. The point is that the attacker, a malicious user, is now executing JavaScript code in the browser of the user, and they can do whatever they want. They can change the application's behavior. They can trick the user into entering their password in a fake form field. They can send requests to a backend. They can abuse permissions from a webcam. They can do whatever you want, or whatever you can do from JavaScript. Not good. And React knows about this. React says like, yeah, we know that this inner HTML is dangerous. That's why we call it dangerous. But they don't fix the problem. They don't apply any protection at all. They just tell you like, be careful. So how do you fix this? Well, the real way to fix that is by sanitizing the data. And my library of choice here is DOM Purify, which is an absolute awesome JavaScript sanitizer. So we sanitize the data, which means we take that review, we feed it into DOM Purify, which is going to look at what you're trying to do. It's going to parse the HTML in a safe way and walk that tree. And it's going to be like B. Oh yeah, that's on my list of safe elements. Awesome. You can use the bold tag. Done. It's going to do that for every element it finds until it finds the IMG, the image. It's like, an image. Let's watch the attributes. Source. Oh yeah, that's on my list of safe attributes. Source is cool. On error. I don't know what that means. So it's probably unsafe, out. So it will keep the legitimate HTML, the benign HTML in there, but it will remove all the dangerous features like on error or script tags or whatever. And what you get as a result is safe HTML. And that safe HTML will render the HTML properly. And what you get is safe HTML, and that safe HTML is what you can include in the page without risking cross-site scripting. Awesome. So what's the takeaway here? The takeaway, and we see that in a lot of modern frameworks, is that we name dangerous things with dangerous. We mark them as dangerous features so they can't be accidentally misused. For example, in Angular, there's a function called bypass security something. Kind of tells you exactly what you're doing when you autocomplete that. Also helps in your day-to-day job, because that React developer probably Googled how to output HTML, found a Stack Overflow post, and if it says dangerously set inner HTML, I'm confident that a developer trying their best will be like, dangerous, what does that mean? And it helps raise awareness, and it helps prevent accidental misuse. Awesome. However, marking something as dangerous doesn't really solve it, right? That's like putting up the sign here, be careful, you can fall off the cliff. It's like, oh yeah, thank you for the warning, but if you misstep, you're still gonna die. Probably, depends on how deep the cliff is. In Belgium, probably not, depends. But that's what we're doing here. We're marking something as dangerous, but we're not really fixing anything. So does it help? What does a developer do when they see this dangerously set inner HTML? Like, what does that mean? I know. Let's look at the documentation. This is, by the way, the full explanation on the React page about dangerously set inner HTML. It's like, yeah, this is risky cross-site scripting. Here's how you can do it anyway. It's like, is that the right message? Let me walk you through this. What do we expect a React developer to do? When they look up this explanation, we expect them to understand what this means. If you've never heard of cross-site scripting, I can guarantee that this is not a very clear explanation. And if they understand what it means, we expect them to look up how to fix it correctly, because there's no mention of sanitization. There's nothing. And then we have to hope that they find the right solution. And given the number of people reading my React security articles on my website, a lot of people find it, fortunately, on my side, but they can also find the wrong solution somewhere else on the internet. We expect them to understand the solution so they know how to apply it, and then apply it correctly in their application every time they use this dangerously set inner HTML. To me, that's a thoughts and prayers equivalent for application security. It's like fingers crossed and hope that people figure out how to do this the right way. And they don't. Here's again an example from a vulnerability in Signal Messenger, a very, I would say, well-designed, well-built product, taking privacy and security quite seriously. And their desktop version was built with React and contained exactly this vulnerability. Whenever you reply to a message, the original reply was dropped into the DOM with dangerously set inner HTML without any protection. So the takeaway here is that marking things as dangerous is not enough. Yes, it prevents accidental misuse, but just calling something dangerous does not magically enable developers to use that feature securely. It doesn't really solve a problem, it just highlights a potential risk. And the second to last keyword word on this slide is important, feature. This is a feature. This is not some one-off weird case that you're trying to solve. No, if you want to output HTML in React, you have to use this feature. Please don't use any of the workarounds which are a lot worse than using this feature. And if we assume that the user actually knows how to apply DOM Purify correctly, how can we verify that? Well, if you want to make sure that you're doing application security right, you have to scan your applications for security. And there's plenty of tools you can use for that. But one of the things I often use in my trainings is SendGrab, because it's very easy to run, very lightweight, and very useful for things like this. They have a React rule set. So if you run this on your application, it's going to download a set of rules and run them, and it's going to give you a report. And in this case, you can see a warning that says like, yeah, this dangerously set inner HTML thing, it's kind of dangerous. You can recognize the text from the React documentation page. You should be careful. And you can see on the line 62, in my application, I'm actually using DOM Purify. Good. This is a 2-minute job to verify that I have properly secured my application. Awesome. You can also see at the bottom 3 files and 1 finding. That's not going to be very realistic. This is a training example. What happens if you run this on a slightly larger application? It's going to be 45 files and 10 findings. Good. Now we're 10x engineered. That was a thing a while back on Twitter. So I don't think this is what they meant with that, but you can see how this doesn't scale very well, right? Because now it's not a 2-minute job to verify that. Now you have to verify 10 findings or 50 findings or 120 findings. And for each and every one of them, you have to see, is this secure, yes or no, and make that decision. And then next time you run the scan, you have to do it again and again and again. And that doesn't work very well. Because what we're doing here is safe, but it's still called dangerous, which makes little sense to me. So what if instead of having to use a dangerous feature, we can fix that into a pattern that's semantically a bit more correct? What if we use safe HTML? What if we have a safe HTML component that takes an element as input, the P for paragraph, and then the data, and renders that review in a safe way? That would be awesome, right? But this component doesn't exist. There's nothing there to handle something like this in a safe way, which is why I am advocating to use this internally yourself. Again, encapsulate security behavior in a component, and it's really easy. It looks like this. It actually works in practice. I've tried it. We create an element. We feed whatever data through DOM Purify to make sure it's safe, and then we drop it into that dangerously set in HTML property. And doing things like this removes that responsibility from developers. The developer doesn't have to know about this. The only thing they need to know is braces for normal data, safe HTML for HTML data. Done. It's called safe HTML to indicate that it's safe by design. So you ultimately get that semantic information from there as well. And that brings me back to this takeaway, like I promised. Encapsulating security behavior is so important because it makes it easier for developers to get their job done, which in turn makes it easier to integrate security. And there's an interesting side effect here that is really, really awesome. If you run semgrep on your application with 45 files and 10 findings, now you have one finding. You can see it's a finding from that safe HTML component. And now I'm going to show you the trick. Well, it's a feature, not a trick. Show you how to make this disappear. You can strike a deal with semgrep and say like, yeah, let's make this our little secret by adding a no semgrep comment to that line of code. Just tell semgrep, I know you're going to find this, but just ignore it. You never saw this. It's fine. Because we have checked this as a security team. We have made sure that this is safe. So we can ignore that and end up with 0 findings. And this has a benefit here. Because you have 0 findings, you can use semgrep to detect accidental misuse of that dangerously set in HTML property. And if you hire a new developer that isn't aware of your safe HTML component because you forgot to mention that, things happen, or somebody has a bad Monday morning and they write dangerously set in HTML and they check their code in, or you run this in the IDE, semgrep will be like, hold on, no. We have a warning about dangerously set in HTML. We don't do that here. We use the safe HTML components because that's how we build secure applications. And this pattern, this benefit is basically using code hygiene to set yourself up for a successful security story. By encapsulating security behavior, your code becomes cleaner, and that makes it easier to apply security best practices at scale. It allows you to use very straightforward scanning tools. You can even do that with a grep. I mean, you don't have to use semgrep. You can use grep as well if you really want to go low level and dirty. But it makes it easier to find potentially dangerous code patterns. Plus, it reduces the amount of knowledge developers have to know, making things a lot better. So to come back to my title, AppSec is too hard. The signs, these symbols at the end actually matter here. It's a very subtle title. Yes, AppSec is too hard, absolutely. I fully agree that AppSec is too hard. After a 2-day training, I have a whole bunch of guidelines. I've given developers a whole bunch of guidelines like, watch out for this, try this, test this, and these and these and these things. I would love to be in a world where I can just tell them, use this and this and this and this, and you're done. We're not there yet, but I'm really hoping we will get there in the future. By the way, security has guidelines, but developers are not security experts. They have to do the same for performance. There's performance guidelines and usability guidelines and accessibility guidelines and so on and so on. So it simply doesn't work anymore. We can't keep piling on secure coding guidelines to developers because that's going to crash sooner rather than later. We have to take responsibilities away in a way that works for developers. So if you want another answer, AppSec is too hard. It doesn't have to be. That's the main message here. It doesn't have to be. Yes, we've had some failures. Yes, we are not necessarily always doing the right thing. We have good intentions, which turn out different in practice. But if you offer the right level of abstraction, the right level of support, and we focus on usable security for developers, I honestly believe we can make things significantly better in the future. And that's exactly what this event is all about. Thank you very much for having me as your opening keynote. And if you have questions or want to chat, I'll be available on the Slack channel right after this session. Enjoy the rest of the event.
Okay. Philippe, before we go, there is one question that I had. So I've seen your talk in London on JWT tokens. One of the questions I had is I was contacting a colleague of mine a while back, and then he mentioned something about looking at proof carrying tokens like macaroons, but I haven't looked at them much. Are you aware of them, and what are your thoughts there?
Yeah, macaroons actually are a bit more complex than JSON Web Tokens. So one of the things they support is to have like sort of a main token from which you can derive less privileged tokens for specific purposes. I think it's a really, really interesting concept. But like I mentioned in the session, it's not like JSON Web Tokens are going away. I mean, if you're using OAuth or OpenID Connect, you're gonna have to use JSON Web Tokens. And the specs are actually doubling down on that by adding new features that also rely on JSON Web Tokens and so on. So in general, I believe that most people benefit from learning how to handle JOTs securely than trying to go for these fairly advanced and more elaborate mechanisms. So I fully agree that there are some use cases where you want that advanced feature and you should look into more advanced solutions then, but most applications, they have very basic problems, very, let's call it silly, very simple to make mistakes. And I believe we should focus on fixing these first before we try to give people something even more complex to implement. That's my take in a nutshell.
Okay, thank you, Philippe.
You're very welcome.